Assalamualaikum and very good morning. I bid to Miss Jana binti Rosli as our lecturer in GBM 20023. Today, I am Mohamad Hazim bin Abdul Mutalib with my team member from Group 8 will present and discuss some equations about differentiation in engineering mathematics. First of all, I want to introduce my group members. Firstly is Amiera Sofea binti Abdul Wahab. Secondly is Nadiah Husna binti Muhammad Zainurain. And thirdly, Hazim bin Abdul Mutalib. And lastly is Muhammad Nasrulhaq binti Muhammad Najib. Okay, the next is team role and responsibility. First of all, Muhammad Hazim bin Abdul Mutalib, he do introduction, example and present. Secondly, Amiera Sofea binti Abdul Wahab, the solution, find stationary points. And thirdly, Muhammad Nasrulhaq binti Muhammad Najib, iaitu solution graph, present and summary. And lastly, Nadiah Husna binti Muhammad Zainurain is complete the slide and edit video. So, by today, I will start the presentation with the meaning of differentiation in calculus. As we know, that the differentiation is used while it is solving problem. In differentiation, also known as a derivative of the function, the symbol of dy over dx was the use by differentiation of y with respect to s. Differentiation basis rule is multiplied in the index of s with the constant for s. Besides, it also decreases in the index of s by 1 unit. As you can see the example to solve the differentiation problem, y is equal as power of 6. If you find the differentiation of the equation, dy over dx equals 6x power of 6 minus 1. The final answer is 6x power of 5. Here, I would like to give an example of application of the differentiation in real life. Firstly, it is used to check the temperature variation. Secondly, is to calculate profit and loss business by using graph. Thirdly, is used to derive many equations in physics. For your information, in seismology study, the differentiation is used to find the range of the earthquake. Last but not least, it is used to determine the speed or distance covered, such as miles per hour and kilometer per hour and more and that. I will pass the slide to Nasrulhaq bin Muhammad Najib to the next slide.
Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon to my fellow friends and lecturer. First, I am going to tell you about the question of the differentiation. Okay, the graph of a curve with equation is y equal to 12x to the power of 5 plus 6x to the power of 4 plus x to the power of 2 multiplied by 9 over x to the power of 2. Okay, the first question that they want is use differentiation to find expression for gradient of curve, and it is dy over dx. Next one is find the coordinates of any stationary points on the curve. Next one is how many stationary points does the graph have? Next one, determine y-intercept point. Determine the nature of any stationary points you found in part C, justifying my own answer. And for the last one is sketch the graph of the curve. So the first one, y is equals to 12x to the power of 5 plus 6x to the power of 4 plus x to the power of 2 and multiply by 9 over x to the power of 2. So y is equals to x to the power of 2, and open the bracket, 12x to the power of 3 plus 6x to the power of 2 plus 1, close the bracket, open the new bracket, 9 over x to the power of 2 and close the bracket. And the reasons there is x to the power of 2 is because we factorize the first bracket. So next step, we're going to find the y, and it's going to be 12x to the power of 3 plus 6x to the power of 2 plus 1 and multiply by 9. The reasons why x to the power of 2 is gone, it is because x to the power of 2 divided by x to the power of 2 is going to be 0. And then y is equals to 108x to the power of 3 plus 54x to the power of 2 plus 9 after we multiply all of it by 9. And the next one, we're going to differentiate it. It is going to be 324x to the power of 2 plus 108x. And the reasons why it's being 324x to the power of 2 plus 108x, it is because 108 multiplied by 3 and x to the power of 3 minus 1, and 54 multiplied by 2 and x to the power of 2 minus 1, and the answer is going to be 324x to the power of 2 plus 108x. And 9, because there is no x in 9, so it's going to be 9 multiplied by 0, and it's going to be 0. Okay, for the next solution, we're going to find the coordinate for x. And as you can see, for a stationary point, dy over dx is equals to 0. So 324x to the power of 2 plus 108x is equal to 0. And we're going to factorize it all. It is going to be 108x multiplied by 3x plus 1 equals to 0. And we're going to separate it all. 108x equals to 0. And 3x plus 1 equals to 0. So x is going to be 0 and negative 1 over 3. Okay, for the next one, we're going to find the solution for y. So we're going to substitute x equals to 0 and negative 1 over 3 into the first equation. So the first one is 108 multiplied by 0 to the power of 3 plus 54 multiplied by 0 to the power of 2 plus 9. So the answer is going to be 9. The first y is going to be 9. And the next one, we're going to substitute x equals to negative 1 over 3. And we're going to put it into the first equation also. So y is equals to 108 multiplied by negative 1 over 3 to the power of 3 plus 54 multiplied negative 1 over 3 to the power of 2 plus 9. So the final answer is going to be 11. And therefore, the stationary point is 0, 9, and negative 1, 3, 1 over 3, 11. Okay, now we're going to find the solution for second degree differentiation. And as you can see, the 648x plus 108 is the differentiate of 324x to the power of 2 plus 108x. And it's going to be 648x plus 108. And at the point x equals to 0, we're going to differentiate this, and 648 multiplied by 0 plus 108, and it's going to be 108. So it is more than 0. It's going to be the minimum point. And the next one, at the point x equals to negative 1 over 3, so 648 multiplied by negative 1 over 3 plus 108 is equals to negative 108. And as you can see, negative 108 is less than 0, so it's going to be the maximum point. Well, as you can see here, we already sketched the solution, and the graph diagram is like this. So for the last one, I'm going to present to you the summary of the solution. And as you can see, we found the cubic type of graph, and there's 3 stationary points that we've been found in the graph. And as you can see, the first solution, we differentiate it, and the next one, we find the coordinate for x and find the coordinate for y, and then we found the stationary point. After we found the stationary point, we can plot all of the points to the graph.